Okay. Hi, good morning, everybody. Hope you have a good break. My name is Wee Hong from Westcon. So we are now, or you are now entering the technical track, right? So on this security and observability solutions on AWS. So without further ado, let me just go through with you the agenda that we are going to have in the next 1-2 hours. Right. So first of all, we have this protect your web apps and API effortlessly in 5 minutes. That will be done by Shanawaz, but from F5. And then we're gonna have enhance your security monitoring on AWS with Splunk, done by Fabian. Of course, then we're gonna have like a securing cloud application that would be by Palo by Setapong, and followed by protecting your deployment and data by on FIPS 140. That will be done by Stefan from Mirantis. And of course, lastly, then we're going to have implementing AWS cost management best practices with HashiCorp Terraform, done by David. So without further ado, let me pass on to Shanawaz. Over to you, Shanawaz.
You be Hong, and I'm glad to be here today. So I know I've got like 20 minutes, and I think I've got the perfect topic for you because whatever we're going to show and tell you, the show and tell will show you exactly how you can achieve some of these things within 5 minutes. So, quick introduction. As I said, my name is Shana Baker. You can call me Sean. I'm a senior solutions architect with F5. And today I'm going to show you how F5 distributed cloud, web application, and API protection can be used to onboard an application and protect it under 5 minutes. But before we reach those 5 minutes demo, I would quickly like to share some of the interesting things that are happening in the world of applications. And I guess it's not any surprise because most of us know that modern application is becoming increasingly complex and there are risks for it. Uh, we are running applications everywhere. We are running on applications on private data center, public clouds, uh, we have multiple personas that are trying to manage this application. For example, we might have app dev doing development, and we have DevOps doing deployments, NetOps managing network, and SecOps trying to secure all these things. So at the same time, all these personas have to ensure that they are also providing Uber customer experience when the people are accessing their application. So no surprise when you have so many different options you have also have different kind of tools and different kind of options to manage them, and which actually makes the life a little bit difficult when you're looking at different personas and their tools of choice as well. And this is when what happens is there are times where you will see that people are not able to actually turn on the exact same capability in different environments in the exact same manner because there are different configurations and different tool sets. So it leaves rooms for some vulnerability in some manner. In most cases, what we have seen that SecOps or security operations teams in their organization will try to build a policy which is targeted towards the application. And these policies should be as applicable to the application irrespective of which platform it is running on. And if there are different tool sets, that means these policies needs to be translated according to those tool sets as well. So this is a challenge that we see, right? In addition to that, we also have visibility challenges when you're deploying application across multiple places, and the preference of app devs, DevOps, and SecOps to use the different kind of tool sets to manage and have the unified visibility. If everything was deployed in one place, there might not be any challenge. But we see, as we know in today's date, application will be spread across multiple places. So how do we get this unified visibility of the app that is across these places? So those are some of the challenges that we aim to solve. And this is exactly what is leading us to this particular problem statement. Like we are seeing that as enterprises and organizations are going into multiple cloud, it does not actually mean that they have a unified integrated operations as well. They might be on multiple clouds, but these clouds are managed in a siloed way. They are siloed operations. The goal of today's discussion on F5 distributed cloud to actually migrate from these siloed operations to an integrator of operations across all the different platforms that we are looking at. And which brings us to the F5 distributed cloud platform. So there are a few key functionalities that I would like to quickly mention before we jump into the demo. I would like to spend most of the time in the platform itself. So you can look at what we're trying to show here, right? That as a distributed cloud platform, provides networking and security services, provides application services, and a centralized management. So things like routers, firewalls, or load balancers can be catered from the distributed cloud platform, as well as providing security from layer 3 to layer 7 with respect to DDoS, a web application firewall, API gateway. All can be consumed or provided by the platform. On the compute side, you can use the platform to run your workloads or a containerized workload and do service discovery and identity management. All these things is centrally managed from the SaaS console that we have, and you can leverage on the AI and advanced analytics that the platform provides. So this unified platform actually helps us consolidate service and lowers the total cost of ownership. SaaS-based operation means that you can get all the goodness that F5 has, and which you don't have to manage a hardware. And you can use a common tooling from edge to cloud to actually deliver and deploy all these services. So that's a little bit about the platform. We're going to quickly switch into what the main topic of today is. It is going to be F5 distributed cloud web or web application and API protection. So, in short, what exactly is the cloud web? F5 is known and has been famous for a lot of application-related security services it provides, including our WAF engine, which was traditionally delivered from a big IP platform. Right. So, and in addition to that, our recent acquisition in the form of Shape services has provided us with a very high efficacy bot detection platform. So we have taken all those and combined in a SaaS-based consumable model. It's not only purely SaaS. SaaS is for management and consuming the service. If customers require, this can be deployed anywhere. So you're not restricted by the availability of F5's distributed cloud's point of presence. You can have your own data center and you can deploy these services over here, but manage it from the SaaS. And the whole thing stating that everything is running on a platform. That means you can add on multiple auxiliary services that the platform has to offer, which can be in the form of application threat intelligence, which is like device fingerprinting. It can be client-side defense, where you can actually look if there is a client on the client side, if the application is leaking data somewhere. So all these interesting functionalities can be consumed and added on to your existing WAF features. Let's quickly switch and see what exactly that WAP as a service has to offer to all the different personas that we have. It's basically a combination of all the well-known services that F5 has to offer. Right? So what exactly are the part of these particular services? So in the web application and API protection, there are four key pillars that we will look at to solving application challenges. A, understanding DDoS and mitigating DDoS. DDoS can be at any layer, from layer 3 to layer 7. We'll be able to handle it for the customers. Next is the next generation web application firewall, which is what we say that our F5 Big IP engine has honed this the engine to run signatures and figure out and find vulnerabilities in the application and mitigate them. There is bot detection and there is API protection. So I'm not going to speak too much about this. Rather than I would like to actually show you how this will be working in real onboarding of a customer's application. So I'm going to stop my PPT over here, and I'm going to quickly switch to the demo view, and I want to show you the platform and how exactly this platform actually helps you and helps solve all these challenges, right? So I can currently see that my browser is being shared. If you're not able to see this browser, please do let me know on the chat. But this is what the F5 distributed cloud platform is like, is the home screen. At the home screen itself, you can see that the cloud platform is able to do a lot more services than just web application and API protection. So there are options like cloud insights, edge sites management. So we can take care of multi-cloud deployments and multi-cloud networking as well. There's DNS management, web application and API protection. These are some of the common services that are mostly used. The whole catalog of services, which is continuously being built and new services are being rolled out, is available in the form of, say, you want to do a DDoS and transit protection, basically layer 3, layer 4 DDoS protection, application traffic insight, client-side defense. A lot of options are available, including managed Kubernetes services that you can use to deploy application. But we are going to quickly see how to onboard an application within 5 minutes to actually solve these challenges. So this is the WAP dashboard that a typical SecOps persona would be using to onboard an application and see what they can do. So quickly going on to the application, I'm going to show a dummy application that we are trying to use for this particular use case. So I have set up an OAuth juice shop application. So for people who are already aware of it, they know that this is one of the most vulnerable applications that is available for testing. It has all these vulnerabilities which is available for you to test it out. So I'm going to take this application which is hosted on this particular domain, and I'm going to onboard this within the 5 minutes to actually protect against different attacks. So this is how it goes. To ingress the traffic into our platform, we have to create something called as an HTTP load balancer. An HTTP load balancer simply requires you to provide it a name, provide information like what will be what will be the FQDN for this particular website going to be. So I already have a domain delegated, or I can create a CNAME based record for an application for any customers. I'm just going to do that. Considering as an application in security, you will definitely want to turn on SSL. So there are two options over here. Either we can go with automatic certificate, which basically says that the platform will negotiate a certificate with the Let's Encrypt CA, or you can bring in your own certificate with the custom certificates. And now all we need to do is it's to point it to an origin pool or an origin application. So in this case, I'm just going to point it to the Juice Shop application that I've already added onto this platform. Next, simplistic. So this is all it takes from the networking perspective, saying that how now FIREs will actually, regional endpoints or POPs will actually advertise this for this particular FTDN. Now we're going to turn on certain security services, right? So we're going to expose this application on the internet. And now for turning on the security services, we can do as simple as enabling a web application in API firewall. I'm just going to turn on a WAF firewall for the starters, and I'm going to turn on an IP intelligence policy. So I am going to show you exactly how these policies and firewalls are configured. So just give me 2 seconds for this particular aspect, because these are some of the steps that SecOps will perform beforehand, and they'll keep it ready for the DevOps team to consume. So that's all it takes to actually onboard an application with an existing security policy that's already there. So I'm going to click Save and Exit. And now we can see that this particular FQDN is created. Right now, the system is trying to negotiate a certificate with the Let's Encrypt. And in the meantime, I'm just gonna check quickly and show you what the application firewall configuration look like. So it's as simple as that. Going to application firewall, create an add firewall, and here you will see that this particular firewall screen that is for SecOps is created to be to induce less false positive and it to be very simplistic in nature. So if you go with the default modes, it just says whether you want to select monitoring or a blocking mode. And if you want to use the default settings, F5 researchers have already making the high and medium efficacy signatures all available to you in the default platform itself. In addition to the signatures, there's something called as threat campaigns that are also included in this default configuration. So threat campaign is F5 threat researchers looking for active threat campaigns in all different parts of the world, getting that information and sharing it with all the other customers. So the threat campaign signatures are supposed to generate at least the bare minimum or close to near false positive. But if you are a pro security person and you want to change the configuration and you want to select the whole set of signatures by yourself, it is also available, and you can select individual categories of signatures that you want to enable or disable for your website. So that's pretty much it for a policy creation. And you can see that with simple creation, you will be able to create this app and the policies are all there in place. So by now, we can simply go back to our load balancers and configuration firewalls, and you should see that the application that we created is already available on the web and the certificates have been valid. So within 5 minutes, we were able to onboard the application, and you will be able to access it as well now. While this is happening, I will also turn on some bots to actually give us some traffic onto the website to show some attacks that will go through the particular platform. So just give me a bit. So you can see that the application is already onboarded and you can access it on the URL that was given. And now if you want to try out some attacks like we like a simple attack, I'm going to do a very rudimentary SQL injection kind of attack. Very rudimentary in nature. The reason why I turned on the networking traffic is basically to show that it's an API based configuration, and you can see that this API was rejected. But since it's API, you're not able to see the error messages. But if you look at the actual response message, you will be able to see more standard FI kind of error message where you have the request and response, the support ID that is available for you to actually dig up and look into the dashboard itself. So that's what it took to actually onboard the application very quickly. Now, in addition to these features, right, this particular platform has a lot more things to offer just on top of, say, the standard WAF capabilities. So if we go ahead and look into the security configurations over here, we have additional advanced features that can be used to turn on things like machine learning config. So the machine learning configuration can also enable to discover APIs, look for malicious user, enable DDoS protection and everything on the system. So all these bells and whistles turned on, what exactly does it mean for the SecOps persona? They can simply come onto the platform, they can look into the dashboard. So within the dashboards, we have two options. We have performance options and security options. So as a security product, you will definitely see a lot of security options, right? But on the performance side itself, you will be able to see that this is a cumulative view for all the web properties that is hosted on this namespace and what exactly is the traffic and how's the error rate like. So if I just go to the one that we created right now, you can see the health score of the application, what's the end-to-end latency like, what's the throughput like, and other informations that be useful for debugging and looking into your applications from a more network-centric perspective. But if you go ahead and look at from the security perspective, if you click and open this application, this was just created and I just ran a scanner for it, you will be able to see that, okay, for this particular policies, we can see WAF events that have been triggering. We can see if there's a generic scanner that's working or if there's a CVE that's trying to be hit. As a SecOps persona, you will be able to see a lot of details that is available within the platform. What kind of users are trying to access it, what kind of automation that the system is seeing, etc., etc. So SecOps persona can simply go into security events and dive deep into any single event that they are looking at. So if they want to look at what attack it is, whether it's this is an automation, so there's a bot Apache Bench is being used to actually fill in the application traffic. So all the information is available in a nice fast format for analysts to actually look into this thing. But if you want to get this application downloaded to your particular platform, you can simply go to JSON. There is an API available for the entire platform wherein you can just make a REST call to the API and you will be able to download the entire data available from here to actually get this information. So this is what a simplistic demo or a quick demo of what I would like to show you with respect to the platform. So we have 2 minutes. If you guys have any question, please do ask, while I will also show you some more advanced features that's available or some more advanced detection features that's available from the system itself. So one interesting advanced thing that I would like to show you is like something called some malicious user detection. So the AI ML piece is actually able to look into the request made by a particular IP address, particular identifier, can be a cookie as well, and see the combine their behavioral anomaly and are actually able to identify this user as a malicious user. The malicious user can be detected across multiple load balancer itself, and you will be able to see where the person is from and why was the person marked as suspicious. So all the information is available over here, and then you can simply mark or block the user. So that's one aspect that the ML part of the product can show to you. So now I'm going to quickly stop and pause for questions. So do we have any questions? Just leaving 1 minute for any questions. If you don't have any questions, it's all right. You can act. If you have any questions that comes to mind later on, you can reach out to us, or you can reach out to me in person, and we'll be happy to share more details. Me back to you.
There's a few differences. Hi. Thank you, Shanawaz, for the
Yeah.
wonderful presentation.
Yeah.
Yeah. And so is there any questions from the floor, from the audience? No, then yeah, we can Or should I just give a countdown? No, so there's no question asked. Then yep, let us move on to Fabian. Fabian from Splunk, he'll be sharing with us on how to enhance your security monitoring on the AWS with Splunk. Yeah, it's all yours, Fabian.
All right, hi, good morning, everyone. Now let's get started about looking how we can enhance your AWS security using Splunk. And before I begin, I have to make sure that everyone understands that whatever your customers purchase should be based on the most current release and what are the available products as well as the available features. And with that done, let's get started. Okay, so just to set the stage a bit to understand what are the problems that your customers may be facing today, right? In terms of the security challenges that the security teams are facing, it's humongous. The most important challenge that they are having today is the speed it takes for them to detect an attack that has happened within their environment. And we are looking at about 24 days of dwell time, according to a research from Mandiant in 2021. So that's the kind of time that we are looking at. It takes the security team to detect a attack that has happened in their environment. And one of the key reasons is compounded by the fact that there's a lack of skilled security personnel. And according to research from ISC2, we are looking at about 3 million people of security professionals that are shortage in the market. And not to talk about, not only that, there are also additional challenges such as the number of tools that an organization use. Globally, on the average, an organization is looking at about 50 different security tools that they have to manage. So think about the skilled personnel they need, the number of tools that they need to be familiarized with, and we have not even talked about them moving from on-premise to cloud to a hybrid cloud environment. So that's the key challenges that the security teams are facing today. Now, that being said, when the customers on the AWS, they are pretty much secure. One of the key reasons is because AWS takes care of the cloud environment for the customers. That means they are looking after the security aspect of the infrastructure, the networking, even the premise itself, whatever that it takes to run the AWS cloud. On the flip side, the customers actually has to be responsible for the application and services that they're hosting there. So there are still other things that the customers needs to look at. And if you start to multiply the number of application as well as services that the customer is launching on AWS, you can start to imagine the amount of things that they have to look into. And very often than not, they have to toggle between multiple management tools just to gain an insight into their security posture. And they have a challenge because they do not have a consolidated view across all the different environments that they have on the cloud, even though AWS is already taking care of the security of the infrastructure. And this is a typical journey that the customers would go through, right? As many of you have been familiar, most of the customers would have started off on-premise, and with the current situation going on for COVID-19 over the last few years, many customers are slowly migrating to the cloud, and some of them are adopting multi-cloud. So as they shift their application and services to the cloud, it becomes more and more challenging for the security personnel. For the SOCs, when they are much more familiar with the on-premise, everything are in control because they have direct access to everything that is hosted within the data center. But once they start to move to the cloud, they have to rethink about how are they performing their security monitoring, how is their security operations going to be run on a day-to-day basis. And this transformation is very important as you start to see a lot more security tools are being moved online, and more importantly, the SIEM are also moving into the cloud. So that's one of the key challenges that is being faced by customers as they transform themselves to be fully in cloud, whether is it on a single cloud or is it on a multi-cloud operations. So that's where it's time to take a quick step and kind of understand where does Splunk stands and what does it mean to be on-premise as well as AWS? I cannot dive in deeper onto how can you secure cloud without looking at what's the key differences here. So the first thing, this is a typical questions that I'm hearing from the customers. They are moving to the cloud, but they are not too sure what are the key security data that they will need to look at. Now, if you start to look at on an on-premise environment, it is very clear. You see that the customers typically would have multiple security solutions. They would have endpoint, you would have network, they have infrastructure, they have application and services. And when it's on-premise, I'm sure everyone here are very familiar with the multiple tools and solutions you have. You probably have the infrastructure like Cisco, you probably have McAfee running on endpoint. And when it comes to the network, you have the various stacks. You have the network switches, the routers, the firewalls, the IPS, and all these are running premise. And that's where the security guys they know where to find this data, where to monitor. And when it comes to the infrastructure itself, from the servers, the operating systems, all these are pretty much something that it's traditional, something that it's not new to the security team, right? So from an SOC perspective, it is just yet another day in operations. And in order to correlate all this data, one of the key things is it is very easy to gain access to information because you can easily send someone down to collect the data through installation of plugin and such. So when it comes to on-premise security monitoring, pretty much it is straightforward. But when you start to move into cloud, then it gets a little bit more tricky here. Because when you are now on the AWS, there are a lot more things to be looking into. There are, in fact, a wealth of security data that is available. And what I have over here are just one of the few data that customers will be looking at. For example, the customers may already have an EC2 instances running in their own private VPC, and they may be leveraging on using Lambda. So there are a lot of things to look at, and that's where customers starts to get confused. They are not too sure where do I get started, what is the data I need, and in some instances they may even miss out key information. So this is where it helps to map it into a perspective that the security operations team would be able to understand better. And that is where you can help them to pull in the right information that is required for security monitoring. And one key thing to note, right, all these data are freely available on the AWS. In fact, there's wealth of it. But the question of what is important, what they should be looking at. And I have broken this down into something that's much more simplified for the customers, whether you or the customers understand, which is to map them into something that is much more traditional in perspective for the security operation teams. That's where they will be able to gain a better insight into what is required. So from here, then they can start to gain a better understanding into what are the things that we really need to look at. For example, from an endpoint perspective, now they can start looking at, hey, I understand that endpoint, that would be EC2. And I may be interested in pulling data from the host itself by the use of OS query installed onto all these instances. And when it comes to understanding the traffic flow, what is going through the environment, then they might be interested in pulling out some of the services that they're already leveraging on AWS, like Route 53, or even from VPC itself. Then from an infrastructure perspective, well, I did mention that yes, AWS is managing the infrastructure, monitoring the security. This information are made freely available to the customers. So one of the key few things that customers really have to get started looking at is at CloudTrail and CloudWatch, as well as at config. That gives them a good perspective of what is happening within their infrastructure. And they might be leveraging on other services on AWS, which is very common. They might have S3 bucket, they might have a WAF, they might even be leveraging on a Lambda or RDS. And with all this key information made available and mapped correctly, now it becomes much more easier to map it across what they are monitoring on-premise as well as in cloud. This gives them a much more synchronized view on what they should be looking at rather than trying to navigate through the forest and figuring out what they need to do. And with all this, especially for customers who are on a hybrid model where they have on-premise services as well as in the cloud, this will be able to tie them in. And with Splunk, we sit in the middle collecting this set of data by applying analytics and help them to see what is the relevant information they need. With that being said, that's one very key thing that it is important to point out to the customer is the AWS shared security model. Well, while I mentioned that infrastructurally, security is being handled by AWS, there are other aspects that customers has to actually dive into and look at from the infrastructure perspective of the server, network, the data centers, the facilities itself. All this are being handled by AWS. And the security content or the information or the data sources that's required, those are made available through the various data sources I have talked about. But customers themselves, they still need to look at other aspects of things. They still need to look at the applications, the services they're running, or even the network access policies that they have put in place to be able to better safeguard their information. So it takes two hands to clap. First, on one hand, you need to know what are the data sources that you need to collect from AWS for monitoring. And on the other hand, the customers still have to play an active part in monitoring their application services as well as the network access control policies. So with these two data tied in together, that's where they will be able to have a better insight onto what's going on and how to secure their environment. Now, speaking of securing the AWS environment, this is where Splunk Enterprise Security comes in. It ties in all the necessary data that we have in the cloud, and we apply analytics the same way we apply the analytics for on-premise security data and help them to look at the quick insights onto what's happening in their environment. So what typically takes hours or days for a security team to dive into, it can be done quickly through the security monitoring. There are preview dashboards and detections that not only look at your traditional on-premise security threats, but it also looks at other aspects as well. It also covers the cloud part of things. And more importantly, we actually tie these two in together so that you have a much more deeper insights onto different perspectives like the IAM network. And it gives customers an end-to-end, much more holistic view on what's the security threat. In fact, the security threat may not necessarily just happen on-premise alone or in the cloud. It may pivot from on-premise and then gradually extend to the cloud. So that's one of the key things that customers need to look at. And having an investigative tool that allows them to pull in all this necessary information to handle the investigation, that is something that's very crucial for the SOC team. And that's where the pulling in the necessary data that is important. Now, you might have heard me talking about data sources as well as the various data. So why are we looking at data itself? Because these are the key information that provides us a wealth of information. And by applying analytics through the different data that is available, it allows us to pivot and look at the data from a security perspective and help us to have much more analytical understanding into this information. Now, one of the key challenges when moving into cloud is bringing this data in. Right? The first part of the problem is understanding what data I need to monitor. The second one is to bring all this data into monitoring. And how do I do so? It may be a bit of challenging. I'm sure you have customers who might have challenges moving or bringing data, connecting to the different security tools just for security monitoring. Likewise, when you are looking at a holistic multi-environment monitoring, it's very important to have a way to help the customers to rapidly bring in this onboarding data. And we have a preview dashboards, we have previous plugin that allows customers to quickly bring all this in. So that brings the speed of them deploying new services on the cloud to a shorter time. And it also reduces the amount of skill sets that they need to fully understand and bring this data in. With that, that allows them to quickly scale across multiple services that they may be running on AWS. And with all this information in, then that's where the key parts comes in. The analytics that is behind Splunk, it helps to look at the different data by looking at statistical as well as machine learning, we help to identify different threats. Anything from a simple misconfiguration right down to an anomalous behavior. And that allow the customers to quickly dive in, look at their security posture through the preview dashboard, and allowing them to deep dive deeper should they need to. Not only what's built in, we also have content that's constantly being pushed update, and these are very cloud specific. In fact, there are many AWS cloud specific content that we constantly push down to Splunk Enterprise Security. This comes together in a analytics story. It covers both end-to-end guides from understanding what the threat is, how do they integrate into their environment, what to do when they have detect an incident, how should they be performing all this investigation, and what is the potential impact and remediation. And all this with together the analytics, the what we call the SPL, which is this Splunk processing language that help them to quickly pull this data, analyze it with a click of a button, and map all this information into MITRE ATT&CK framework and tactics, so that helps the security analysts to have a better view of what they are fighting against. And we also have the investigation workbench. That is a tool that most of the customers will be using from the SOC analyst perspective, because they can quickly pull in what we call notable events, or you can look at it as an IOC and piece them together on an investigation. And with that, once they dive in and perform a deep dive into further investigation, this information can be captured inside the investigation workbench, allowing them to have a quick view on what is happening. They can build a case out of it. They can manage it through multiple team members engaging together to investigate as well as to close it. At the end of the day, this can be printed out and submitted as a form of report as well. So what's the most key thing about when it comes to Splunk? It's really the security monitoring. We look at multiple data sources, whether it's as long as an unstructured machine data, we can pull it in. So gone are the days where customers will be challenged by looking at what are the security technologies that will work with the SIEM. In this case, as long as the data is machine readable, human readable text, we can bring those data in and perform analytics and security monitoring on it. And more importantly, it's when it comes to advanced threat detection. Because we apply analytics, we can now look at low and slow threats that happens not just in days, but across weeks and months to understand what is happening, what is the parts of the process of the attack that's happening, and we mapped it to MITRE ATT&CK techniques so that the SOC analysts will be able to better have a visual view on what's going on in the environment and at which stage of an attack are they under. And with that, there is also the investigation workbench that we talked about that allows them to quickly see it, visualize it, and collaborate with the rest of the SOC team. So how can we integrate Splunk together with AWS? There are a couple of options that the customers can choose for. They can go for a SaaS model, which is Splunk Cloud, or they can simply deploy Splunk in their VPC through a preview AMI. Alternatively, there are some customers who would choose to build their own Splunk enterprise stack. So these are the three common options that the customers typically will go for. And with that deployed, we can pull in the data from the various data sources throughout AWS. There are a wealth of data sources, as we have seen earlier, that we can pull into to provide a much more comprehensive view. And one of the quickest way to get customers started is we have developed an app called Splunk App for AWS. This is freely available on our Splunk base. Splunk base is an app store for Splunk app. And customers can download multiple apps. And one of it is Splunk App for AWS. And Splunk App for AWS allows customers to quickly look at their security overview. They can quickly ask questions like, what are the number of changes in the security rules in my environment? And what kind of activities are we seeing? Is there any unusual provision activities that's happening in my AWS environment? So all these answers are quickly answered in the security overview. And all these dashboards, all these use cases that we have built into this app are actually use cases that we have worked with our customers globally to find out what are the top use cases that is the most relevant and useful for them. And the other thing that they can look at is also to look at the VPC flows to understand the different security activities that's happening. And customers will be able to dive in deeper into the VPC config and see what are the block traffics that's coming into the VPC, and they can look at other things as well. And they can then dive in and pivot into other security investigation should they find a need to. And we can also dive in further, looking at what are the different security groups that is available inside the environment. Is there any unused security group? And these are not the only set of activities or use cases that customers will be able to see. We can actually pivot from security right up to the IT operation side of things. So when customers start to invest in Splunk, they are not just investing in a security monitoring tool, but they are also investing into an IT operation tool. So customers now are able to quickly look into billings. They are able to look at the topology that they have within the AWS, and they are able to dive into the usage of the different EC2 instances as well. So that all these use cases have been built into the Splunk app for AWS, and customers can just quickly get started with it right on day one. And that is not the only apps. Like I mentioned, these apps are available on Splunk base. It's an app store for Splunk, and customers can just download and install all these apps for their use. And majority of these apps, I would say about 99% of these apps are free. These are apps developed by Splunk, by our partners like yourself, or by customers themselves as well. And you will be able to easily find any apps that's required for AWS. Just do a quick search on Splunk-based AWS. You will have tons of these apps available. And if customers is interested in other types of technologies and integrating them in, they are able to just do a quick search on it. And we are a market leader in terms of security. We are ranked #1 in the metric quadrant. Not only that, we are also #1 in market share for IT, as well as a visionary for observability. So when customers get started on security, they are just starting their journey on Splunk for one use case. And most of the time, when customers start on security in Splunk, they will pivot to IT, and they start to look at other sets of use cases. The reason why they are doing so, because we are fundamentally a data platform, which is why we call ourselves the data to everything platform. Once we bring in the necessary data, say for example, all the security related data on AWS, we can then pivot this information by applying a different lens and reuse about 80% of this data for other use cases like IT. And that's where customers get the true value out of Splunk, not just investing in one security monitoring tool, but they are now investing in the Swiss Army knife. And with that, that's pretty much the end of my presentation. So at this time, I'd like to see if there's any questions for me. Okay.
No.
If there's no questions for me, then I will hand it back.
Right, thanks a lot, Fabian. Again, that's another wonderful sharing from Fabian of Splunk. So, yep, let's bring up Setapong from Palo Alto, and then he'll be sharing with us on the securing cloud application. Over to you, Setapong.
Thank you. Thank you so much, everyone. Okay. All right. My name is Setapong. I'm working at Palo Alto as a solution architect for Prisma Clouds. Okay. Today, we're going to talk about like how to secure cloud applications, right? This is agenda that I prepare to sharing to everyone, right? About the challenges, about risk, okay, industrial standard, how or what Prisma Cloud offer. And I will bring up one, I might call that some kind of incident that happened last year about like zero-day exploit or zero-day attacks, right? Okay. First, look at the key challenge that happen every organization that facing about the security on the cloud era, right? Yeah, because there's a lot of numbers growing that they need to protect, right? It's going to be either IaaS, PaaS, even cache, right? So many type of like cloud workload that coming up, not just like host or VM, right? That is one some kind of the challenges. And the second one, right? Enrollment are constantly changing, right? Developers, right? We're talking about DevOps, right? DevOps, I have a process, build, ship, runs. Then I can build the application and push it, deploy it, right? Without any security guardians. That is the second challenge, right? And the third one, right? Everyone, okay, is stakeholder. I would like to build every state with the security, but okay, we don't have any people to doing that, right? Then every people either gonna be operation, developer have to take security as well. Otherwise, it's not gonna be secure on the application. They will stop at security at the production. Yeah, that's the thing. Then look at some kind of risk that happens. Okay, this information, okay, we got from Palo Alto Unit 42 research. Okay, these units, right, or these department, they have like red team and blue team that they searching and do some kind of like analysis and publish the paper that you can look through the website as well. For the cloud side, right, they found that 43%, right, of the people who using like a database as a service, right, they are forget to encrypt it. This risk is leading to like data loss, right? Maybe this kind of risk that happen from like human error or some kind of like unsecure code if you're using about like infrastructure as a code to provisioning it. The second one, okay, now we're talking about like containers, right? Those images can be downloaded from like open source, right? Either the Docker Hub or Quay. But the thing is, they found that 91%, okay, the base images contain critical and or high security in terms of vulnerabilities. If you build an application with these base images, okay, that are also a risk into your application as well. And they found that people who are leveraging some kind of a cloud, yeah, there's some kind of insecure network configuration that happens. Maybe you would like to add some more port on your security group, but somehow you have to look through that those loop that you're gonna add is affect any other or not. Okay, this one is something that we found that is a misconfiguration about like 60%. Okay, and we found that 66%, right, of organization using access key, which is longer than 90 days. It means if I using like GitHubs or whatever, right, that I left the key outside for some time, and if my repo been exploit or some people scan too, then they can bring up and use those like access key and secret key to compromise the cloud application as well. This is something that we found, okay, in the cloud world. Now, look at some kind of industrial standards, right? If we would like to secure our cloud native application, we have to start somewhere. Yeah, we can get some either best practices or some kind of like standard framework. Today, most of people talking about like CSPM and CWPP frameworks from the Gartner. Two frameworks have released it in 2018. Gartner split in terms of like cloud security posture, okay, to focus on some kind of like control plane, how you configure it, right? How the compliance that happen from misconfigurations, those kind of stuff that the CSPM framework will capture and report it. And also a second framework is CWPP, Cloud Workload Protection, to protect your workload across like public cloud or multi-cloud or hybrid cloud, which is given by Gartner. But okay, last year, Gartner released another new frameworks, okay, by combine two of framework, CSPM and CWPP, okay, and adding something called like artifact scanning, which is in short, you can think about like source code scanning like set and that, right? In this case, right, the new framework we released last year, they call the cloud native application protection, to make sure that those applications that leveraging like cloud infrastructure will be secure from like the build, okay, ship and run. Okay, now look at the what is Prisma Cloud offer to secure the cloud. Okay, when we compare with like CNAP, that the new framework from Gartner, right? We solve like common issue, right, with the simple use cases. Number one, right, we provide visibility and compliance. How you gonna secure if you don't have a visibility? This one that can bring up in terms of access, right, in terms of like configuration and including compliance that you may need to follow regulatory compliance in your location or in your countries. And number two, okay, we provide some kind of like risk management. Okay, this will let you understand, okay, risk that happen to your business. Because look at, right, if we look through some kind of risk that happens, right, there will be a lot. But which one is we have to pay attention, right? That's why we provide some kind of level of severity, the risk that happen in your environment. Okay. And the last one, we provide, okay, automate response, or maybe you can call like auto remediate, right? Or something like we call like automate. This one will help in terms of like SOC operation to dealing with the scalable, right? Because now you have multiple workloads, but don't expect that organization gonna have multiple security team to help you in terms of operate. Then automate is helping this kind of issue that happen from the Prisma Cloud. Okay, Prisma Cloud, okay, offer as a platform. Okay, when I say platform, that means people or customer can use one of the file or use all file. It's fine. Okay, it depends where customer want to start, right? I will go to the first one. Okay, on the left hand side, they call like DevSecOps. Actually, this one we can help you to secure infrastructure as a code, right? Today, I found that a lot of organizations start using like cloud operating model by leveraging automation from like either Terraform or AWS that can use like CloudFormation. Okay, how we can make sure that the code that you're gonna use to provisioning infrastructure is more secure. This kind of capability can help you to scan to the code first before you put into a CI/CD pipeline to provisioning the infrastructure. Okay, and the second one is about like security posture management. This one is looking to your cloud infra, whether you are provisioning infrastructure properly. Okay, let's say if you don't use some kind of like infrastructure as a code, you still go through like manual by either use a CLI or like console. We are able to help you to check through either your EC2 or S3 bucket has config proper or not. Yeah. And also we provide some kind of like cloud workload protections. Okay, this one will protect your workload. Okay, and when I say cloud workload protection, what does it mean? It means cloud workload. It's not just like host, it's not just VM, right? It means like container, it means like serverless, right? And this one has a change in terms of like characteristic of infrastructure of the workload. That's why you need a proper solution to protect. And this solution also integrates, okay, with the software development lifecycle that you need to implement it in your organization. And the next one is a cloud network security. It's about like how we can do like micro segmentation. Okay, how we do segmentation. In the past, when we talk about like segmentation, we think about, oh yeah, I can use VLAN. Okay, until VXLAN come in, because we on what they call virtualization era, right? But now we are on like cloud native. Yeah, we're leveraging like containers. With the old approach is can make segmentation. The answer yes, but it may complex and can be a misconfiguration as well. For our solution, we leveraging some kind of like metadata on the workload to make some kind of segmentation in the container environments. Okay, and the last one It's about like cloud infra entitlement management. It's about how can I make sure that how can I calculate it. The permission that I give to user is a right side, not over provisioning, not less. This kind of tool, I mean, this kind of capability can help to make sure that we giving the right permission, right side permission to the right user to reduce some kind of like surface attack from the IAM standpoint. This is something that Prisma Cloud, okay, offer as a platform that customer can pick and choose to start, okay, to secure a cloud native application. Okay, now I'm gonna bring up to one of I might say use cases or that how we identify and protect against like remote code execution 0-day exploit. Okay, I think people around here that we heard about like Log4Shell, right? That happened last year. In this exploits, right? I got the call from customers and my partner to asking, hey, is Prisma Cloud support this? How to identify it? Yeah. Then I have to explain that, hey, okay, as you remember, right? We provide some kind of at least number one visibility, okay, and risk management, and also some kind of like automate, which is can be used to identify and protect against like 0-day attack as well. In this case, it's Log4Shell, right? Okay, let's go through that. Okay, we have number one, Prisma Cloud have intelligence team, okay, to detect Log4j. Okay, number two, okay, we have some kind of like defender or runtime defense to protect runtime, like cloud workload protection, which is make sure that when misbehavior happen in your application will be prevented. And the last one, we have RQL, which is you can do some kind of investigate further. If you putting your cloud workload in the cloud and your workload might have some Log4j inside, and then you can look to that, hey, is there any communication happens, okay, from the workload that have Log4j and communicate outside. This is the three key things that we identify and protect against Log4Shell. Okay, look at number one, right? As I mentioned, we have like intelligence team. Every time that BCE got released, right, we will have a team they call a Prisma Cloud Lab team, okay, to verify those BCE is really has a issue, okay, to make sure that it's not going to be like false positive. After we verify it, we test it, okay, we'll push it into the intelligence team, okay. As the customer side, right, the customer just go to the consoles of the Prisma Cloud, okay, then go to Vulnerability Explorer, okay, just type exactly CVE that the customer concern, okay. If CVE, okay, that release it to the console from the stream, I mean intelligence stream, and they will search in your environment. If your environment has some kind of what they call package or image that contains Log4j, in this case, right, they will show up here. If you type the correct CVE number, it show nothing here. It means like you are safe. This is the first visibility that we provide, okay, to your cloud native applications. And then let's say, okay, you got it. In this case, right, we found it one. We have to prevent that the new container will be deployed from the image that contains Log4j will be prevented, okay. With the Prisma Cloud, okay, if you set up the rule to enforce that, hey, if you would like to deploy the applications, okay, that pull the application from registry, we have to make sure that the new image that been deployed, okay, is not affect with like high CVE, CVE that has critical security to be deployed in the environment. Because as a user, right, user may use like CI/CD tool to deploy. He may use some kind of like automation. Then he would know, right? In this case, right, we can integrate with the automation. Then we be able to prevent the image that contain Log4j to deploy in the productions. And the third one, right, Of course, must be existing application that contain log4j up and running. If that application got compromised and have misbehavior, right? That means, like in this case, if you can see, right, my application never run like the build guest -o before, okay, and connect into HTTP, which is something that never happened. In this case, okay, our runtime protection will be, okay, prevented. That will not gonna happen in terms of like zero-day attacks, right? And then we also provide some kind of web application and API securities, right? When we discover log4j traffic coming in, right, we will provide some kind of virtual patch, right? With the virtual patch, will help you to prevent and block exploitation from log4 shells, okay? And with the some kind of virtual patch or some kind of like a custom rule, this one will be released from the Prisma Cloud Lab team. Okay, user is just add it and use it, right? You don't have to write up the virtual patch, right? Those virtual patch will be take care from the Prisma Cloud Lab team, and that one, because of there's no any some kind of like patch updates from the vendor release it, then this case we will prevent your application from virtual patch that released from the Prisma Cloud. And then we also helping in terms of like visibilities, right? If you have the workload up and running, okay, you can use like RQL, okay, to query that, hey, if the host, okay, that contain log4j has communicate outside or not, then you can take investigate further, okay. This is something that we provide and handle some kind of like zero-day attacks for you, okay. For key takeaway, right? Those people or those users leveraging some kind of like innovations on the cloud, okay, it's going to be public, private, okay, and Prisma Cloud definitely can secure the business because we make sure that application that up and running is secure, then we can secure business, and we are not the barrier to stop the business. We integrate, okay, security in each stage, okay, from the build, chip run, or even you have implement some kind of like chip level security, then security gonna be at speed. And the last one, okay, we helping to save business as well. Forrester has a total economic impact study, right? They found that customer that who using Prisma Cloud that get the ROI faster at 276%. That can save the money that customer invest with the security on the cloud. Is there any questions for my presentation? Anyway, thank you.
Hi, Weihang. We can't hear you for some reason. Just check that you're... There we go. Perfect.
Hi, yes, yes. I'm so sorry. I didn't realize that I was muted the whole time. So yeah, I was saying that yep, I'm sure there are more for Hong to share, and thanks a lot for his sharing. So if there's any further question, or if you wish to like reach out to him, feel free to let us know. We are happy to link you up with Setapong and his team at Palo. So
Yeah.
yeah. So thanks a lot. And so next we bring up Stefan from Mirantis. Stefan will be sharing with us on protecting your deployments and data. Yep. Over to you, Stefan.
Hello, thank you. Thank you for having me there. I believe we can see my screen. Yeah. Okay. So hello everybody. My name is Stéphane Montré. I'm working as a cloud solution architect at Mirantis. So if you don't know Mirantis, this is the company who acquired Docker Enterprise late 2019. I had the chance to work in this cloud area and container Kubernetes ecosystem since almost 5 years now. And my goal is really to help companies to, or we say in Mirantis, to ship code faster, but also in a secure way, whatever the infrastructure is. So to give you some context about Mirantis, so Mirantis is coming from the OpenStack business at the beginning and made a shift into the container and Kubernetes area. And really the goal of Mirantis is to help customer by simplifying how they will work with cloud native infrastructure. Meaning to be able to bring any container on any cloud everywhere. And this with three simple words. So first one is choice, because we give the choice to the customer in the way they will deploy the Kubernetes infrastructure with simplicity, because we also aim to simplify the way we deploy Kubernetes infrastructure, and we also simplify the access to the technology, especially for developers. And of course, and it's also the topic of today, with security. What is really interesting is that we also then provide a consistent way of deploying our platform, whether it's public cloud, private cloud, environmental, etc. So again, really, the idea is your cloud everywhere in order to enable the capability to ship code faster and really to focus on developing application. So in order to really give you an overview of that, again, Mirantis is coming from the OpenStack environment. So you see on the left that we also still provide some virtualization to our customer, and on the right, all the stuff about containerization. And in the middle of that, we also have one solution, which is Container Cloud, which will enable to deploy our solution on any environment. Meaning Container Cloud will really be the entry point in order to deploy our solution, whether it's on public cloud, private cloud, of course on AWS. And also what we bring also together is the fact that we deploy the solution in a secure way, and we'll see how we leverage the FIPS certification, the DISA STIG, also to help us to bring this security, but also by providing a secure registry, which will be private for the customer, and also with some vulnerability analysis for the Docker images, in order to make sure that the images that you will deploy in your environment are secure. And also observability is another stack really important. And for that, we ship with our Kubernetes environment a component that is called Stacklight, which is basically a stack including Prometheus, Grafana, Alerta, Elasticsearch, Fluentd, Kibana, etc., in order to provide a standard way of observing what's happening in the environment. And also we have Lens. Lens is a Kubernetes IDE. Maybe you already know it. We have a really good traction in the market with this open source tooling, which is used now by more than 500,000 people, mostly developers, and which also brings the simplicity to accessing Kubernetes environment. So you understood our focus is really on providing to customer container runtime, Kubernetes engine. So for customers to have a support in order to deploy their container-based application, whatever the environment, and especially for AWS. So we're able to deploy automatically from Container Cloud to AWS, and in that way, we take care about the infrastructure and the deployment of the our platform, which means that Container Cloud will also manage to deploy all the AWS infrastructure, like a VPC, the subnet security group, etc., and all the EC2 instances on which we will deploy our solution. So to summarize the container portfolio at Mirantis, so we bring the container runtime, which brings also the capability to secure the deployment with the FIPS integration. So this is really regarding how we secure all this. And of course, this is on top of the hardening that you can bring on your machine. And then, of course, Kubernetes Engine, which is our Kubernetes distribution, will leverage this container runtime in order to manage and run containers. The other one, which is really interesting and important as well, is the secure registry, which will be the private registry for our customer in order to store images. And each time you push an image to the registry, sorry, there is a vulnerability analysis that will be launched. So in order to identify in the layer of the image if there are some vulnerabilities. But the registry will also be able to define some promotion. You can define some rules in the registry to say, okay, for example, if my image has more than 3 critical vulnerability, we won't allow to deploy that image into any environment, whether it's dev, staging, production, etc. And on top of that, we have the Lens IDE, which can also integrate some kind of security and observability, because Lens will be able to use any observability stack you have in your environment, and to display also in the UI some information about the usage of in terms of CPU memory of a container or whole application, and also with some extensions that we can add in Lens in order to add some features to the product. We can also add some security features. For example, we have an extension with Aqua Security called Starboard, which also provides some analysis of the image when you deploy. And for a developer, it's also quite interesting and important to know when they start to developing and testing images that there are some vulnerabilities or not in the product or in the container. So really, the 4 words that you see on the right, we want to make it simple, to make it fast, because we can deploy quickly and with some lightweight also distribution that we can provide with a reliable solution. We have customers that are running our Kubernetes solution with a lot of clusters, with a lot of nodes, and running critical applications. That's also really important because we all a lot of time think that Kubernetes is really nice, but is only intended for stateless application. But we also have customers that are running stateful system and critical banking system as well, where security by default is really critical, and which also make this solution really scalable regarding the type of workload you want to deploy, and we can go, of course, from really small deployment with some, let's say, IoT edge computing use cases, but also again with a critical application. And all this, of course, will be included in what we call the secure software supply chain, because this is what customers are looking today, how we can integrate such solution with the security needed into the supply chain. And this is really what we want to do. Also, help customers and developers to develop in a secure way, and then run also the containerized application in a secure way. So security is fully present at each step of the supply chain. Of course, you know all of that. We can secure your CI/CD pipeline, and we at Nuantis will provide the security needed with the registry and with the FIPS certification. And when you apply all the security control, again, so at each step, at the build, the share, the run, with the registry again, and also what we see on the right is that when also we run the container with the help of the FIPS certification we bring into the runtime, this also bring this level of security that is needed in the environment. So what is FIPS? So FIPS is a standard, so-called Federal Information Processing Standard. It's really a standardization to validate the cryptographic module. You have several levels of the FIPS certification, coming from the level 1, which provides some cryptographic module, to level 4, which is a fully complete hardened system. So under this, we are at the level 1 -2, because it's really a software component that we bring into our environment. And when we look at which type of customer, which type of industry really need this, obviously, of course, that a government agency, banking, highly regulated industries are really looking to have this kind of certification. And it can be really also quite important in terms of work in order to have this certification ready for your system that you want to bring to customer. So it's a huge work in order to get the certification, but also a nice proof that your solution is really secure. This FIPS certification is provided in the Nuantis portfolio with the container runtime, which will, as I said, be part of the Kubernetes engine. And we also have another distribution called KZOS, more lightweight, which is also FIPS certified. So this is really important because we are working with customers that really need this kind of certification in order to really provide this key management and data integrity that is required for them. And what the customer take from this is really the capability from this FIPS certification and the container runtime to encrypt the sensitive data in order really to reduce the attack vectors. I mean, you had also agreed the presentation from Palo Alto just before me. Also bringing container into the game is also providing some new surface of attack that is possible in your system. So it's really important to have this certification in order to validate that we can manage and work on this type of attack. And the other let's say certification or regulation system is a DISA SCIG for Security Technical Implementation Guide. It's most like a questionnaire in a checklist on security in order to validate that customers are doing this good thing, the right thing in order to secure the environment. It can be from the machine itself to also some specific regarding container and Kubernetes environment. So, for example, also for Kubernetes or for Docker or for Linux, you have the CSI benchmark that exists in order to check that all the security aspects have been managed and are correctly configured in the product. Just checking the time. So in the same time, of course, Mirantis and is bringing this STIG again to bring some more value to our customer in order also to be aligned with any industry standard for security that people may require. For example, I'm working with a big bank in France, where security, of course, you can understand, is very critical. Um, and not only they are using the registry, the secure registry, in order to ensure that all the images are secured, do not contain any vulnerabilities. Of course, they also have hardened the systems as much as possible, but also they need to comply with this standard in order, for example, with Kubernetes, there is a specific SCIG for Kubernetes, which we follow also on our side in order to provide this level of security for our customer. And then this is valid whether it's private cloud, public cloud, because it's still on top of the security that you can already have within your infrastructure. For example, you have some items of the SCIG checklist for Kubernetes. You have, for example, the etcd, which is the brain of Kubernetes, must use TLS to protect the confidentiality of the sensitive data. You must have the insecure port flag disabled for accessing the Kubernetes API server. You should not have SSH running on the worker node because you don't want that someone to connect directly to the worker node, etc. So there's a set of items to check within the configuration of your Kubernetes cluster or environment that must comply to do standard with the STIG. So we spoke about security and all or which certification, which standard we comply to at Mirantis in order to provide this level of security to our customer. But security also imply that to have some observability. I said before that with the observability, we provide a package which is called Stacklight in order to get metrics from the infrastructure, but can also be used to get metrics or observability of your application. And when it's about infrastructure, so we get metrics with Prometheus, we display them with Grafana. We also enable logging to all the information from the infrastructure with the EF-key stack, the Elasticsearch, Fluentd, Kibana. And of course, what is really interesting is that then we provide some out-of-the-box dashboard with Prometheus. So this is an example of a cluster that has been deployed with Container Cloud I spoke about before on the AWS infrastructure. So which is really interesting that it's really going on top of what AWS is proposing, because we also then provide some specific dashboard or information regarding the container and Kubernetes infrastructure. So of course you have the same with the logging with Kibana, providing logs about the environment. Of course, the cloud provider interface is providing some kind of information, but what we also aim to do with this is also provide some specific monitoring or logging into the Kubernetes infrastructure on AWS. So as a summary, and I will finish with that one, and also to keep some time for the next people to speak. So what we provide with Mirantis is really a verifiable security processing because we get the certification which has been renewed for the FIPS one last summer, and so it is valid until 2025. The SCIG guideline are just some example about the security implication that we want to provide with our product. You also understood that we provide a secure private registry in order to secure Docker images. But not only, we also are able to store Helm chart in the registry, so you can then have a full storage, secure storage of images and MChart, which are the packaging of Kubernetes application. And of course, with Stacklight, we also bring the required observability for the Kubernetes workload you want to deploy, again, whatever the infrastructure. And I also put a link to the Kubernetes hardening guide, which has been released also some weeks ago. And it's also really interesting in the way of understanding what is required in terms of hardening for your Kubernetes environment. That's all I wanted to show or to present. I'm open for any question if there are any.
All right. Thanks a lot for the sharing, Stefan. And I really appreciate you joining us today. I know it's still early in the morning hour at your side, right? So hope you have your breakfast or go for your breakfast soon.
I will
Yeah.
have.
Right. Cool. Thanks a lot. Right. We hope to see you
Thank
soon.
you.
Thank you. So, yep. Let's bring up David from HashiCorp. He'll be sharing with us on the implementing AWS cost management best practices with HashiCorp Terraform. Yeah, over to you, David.
Hey, Gan. So my name is David Wright. I am a partner solution architect here at HashiCorp. I have been fortunate enough to be working with our partner communities for the last couple of years. That's included working with our cloud providers. And so across that, I've come up with some best practices, some mechanisms to be able to implement, and hopefully for some information that you can leverage and take advantage of as we go through this. So I just want to kind of set the stage and set some problems. Obviously, we know cloud is obviously growing. We know that the last 2 years of lockdown and pandemics has driven cloud to accelerate. We're seeing more people working from home, more capacity around being able to work around digital workloads. My local coffee shop, who 2 years ago would have laughed if you said, "Can I order this online?" now has a full online ordering service that you can use and preemptively set up. So people are becoming or being forced to become a lot more digitally first. A lot of organizations have accelerated their consumption of the cloud and trying to drive workloads to the cloud to meet those customer requirements. Obviously, we can take some really primary examples with like the banking industry. Nobody wants to go into a branch, so how do we fix that? How do we allow people to still get mortgages, still be able to buy, sell things, get money, and deliver all those things? So now the digital experience has become the primary interaction for those guys to be able to have, and win customers. So not only are customers demanding it, but businesses are also looking to acquire customers through that better digital experience. And all of these things are obviously driving a lot of the cloud consumption. But as we know, there are some big numbers that go along with those things. So, for example, at the moment, there is about 37% in the latest cloud survey that reckon that they are over provisioning resources, or 30% of organizations are over provisioning resources, which amounts to about a $17 billion wastage. And so that's a fair chunk of change to be, paying for things that you're not actually getting value around. So as that growth continues, so will that growth around why we are looking and why there are wastages. And I suppose what some of those wastages are tied to is people and process. And one of the things that I'm speaking from my experience, and I'm longer in the tooth than I'd like to care to admit, but I know from my experience that when I first started in the IT industry, there was a strong ITIL process. That process, a developer put in a ticket, the ticket would come through a workflow to myself, I would pick it up, and then build infrastructure around those parts. But that building and infrastructure had an inherent control mechanism and cost control built into that. I could see visibility into, is this a funded project? Is this going into an environment that they're going to fund themselves? Is this BAU work? Who does it fund? Where does it control? Does it go under? Will it fit under our maintenance contracts? So all of those types of costs were thought about and factored into the process. So there was a degree of it just magically kind of was integrated into the process. What it didn't do, obviously, was help organizations pick up the cloud journey, right? It doesn't make for a speedy process. I know when I was working as an infrastructure admin, we had to wait 6 months for a box to turn up. It was a key project, and we all had to wait 6 months before we could do anything on that project. Nothing we could do about it. That was the nature of it. That in turn obviously slowed a whole bunch of additional innovation and resourcing around that. So having people who couldn't start to experiment, we delayed projects, all of those things. All of those innovation things and the digital move to a digital kind of criteria that I spoke about at the start, with customers forcing and needing that better digital experience. So the two were starting to actually obviously conflict against one another, which is why as the move to cloud has kind of developed, so the use of infrastructure as code has kind of really fully expanded and been adopted as a way to drive that cloud migration and those cloud adoptions. And fundamentally, that's because we're taking a code approach which brings down and uses a central source of control through that version control. We're taking an automatic process that allows you to then run at speed and deploy repeatable resources quickly and easily. However, and this is where people and process come in, whilst that's good for for solving the digital experimentation, innovation, driving change and allowing to get things built quickly, what it doesn't necessarily do is then pick up some of those older process controls that were integrated into that ITIL platform, for example. So who is going to budget this? Like, who does it own? Who does it belong to? So is there mechanisms putting in controls around that? Who's the cost going to be attributed to? Who owns it? Who's going to pay for it? Or does it just come out of the magic cloud bucket that suddenly that bucket's getting bigger and bigger? Who's actually proactively monitoring whether that resource is needed? So one of the stories around having a cloud model is around elasticity and on demand. Now, if you are building resources and automating and spinning them out, but you're not then proactively managing that, that becomes a problem in itself, because now you have these instances of being spatially driving that. And this thinking and this approach is perfect for allowing you to innovate and move quickly. Doesn't necessarily incorporate the thinking around how to provision and stop over provisioning of resources. And so these two things are then conflicting against one another, and so the process in trying to actually understand how to control this becomes this paradox where we have to try and fit in against one another. And this kind of becomes even more apparent as we start to expand around when we think about how cloud adoption is done within an organization. So first of all, you have maybe an individual or a couple of team members that are saying, well, we want to go to cloud, we're going to innovate, we're going to move these first couple of workloads. And so they set up some accounts, they come up with a proof of concepts and some value concepts, they push that first application, and there's a really clear sense of cost and control around the application, how much it costs, what workloads we spun up, it was only run when it needed to, and the cost justification, easy for some to say, goes back to the business with some very clear data around what that return in investment is. And so there's no surprise to the business. It seems to be a no-brainer in terms of moving resources to the cloud. So now that they go, well, that's a good idea, we should do more of that, and they come up with a mechanism to deploy more resources. So they come up with their cloud COE, so center of excellence, they start to tie together and look at how they can optimize those. They work with their AWS and their cloud optimization tools around, well, actually, this stuff could be, we can use it to a more productive instance. We can start to look at how we do spot pricing. We can tie this into into a proactive way of turning off their resources. This was dev, and so the costs come down, and so suddenly cloud is looking even more cost beneficial. So now that we have that benefit, we're going to our teams, right, this is what we're going to do. We're going to roll it out to everybody. This is the best thing ever. You should all be doing this. And so as those teams start to then create more accounts, they start to look at how they can do more applications and dev quests, and those costs naturally rise. And everybody is thinking that that cost rising, or those rising costs, should I say, are based on best practices and the defined that the COE created. However, what tends to happen is more and more teams come into that scenario. So more and more random, well, not random, but more and more accounts are actually created, which means that you lose that span of control. People start to experiment with new services, bring on new instances, bring up new scenarios that add in additional costs. Those applications and other applications come into play, and suddenly now the optimization that you had back at the start with the COE team and looking at how they can reduce those costs hasn't been done because there's multiple accounts and everybody's making assumptions that what is being built is being done based off of those best practices, and the costs start to rise and spiral. And so then you'll end up with this scenario where suddenly you're getting these massive bill, and the organization has to say, well, how come we said at the start, way back in before we even had a COE, that this was going to save us gazillions of dollars, and now we're looking at this and it's actually costing us more than if we'd actually built this on premise. And so what we need to do is think about how we can actually put in some fundamentals around looking at what best practices are and how we can actually solve for that challenge and make sure that users get the best out of the cloud whilst the business gets the best out of the cost optimization. And so if we work at and look at AWS and how they put their best practices around it, it centers around these kind of 5 key areas. So one of those being tagging. Tagging and tagging enforcement. So tag everything, tag it twice, tag it 3 times, to coin the old phrase around doing something. What this is doing is ensuring that you know who the resources are, who owns them. So going back to that, that old ITIL process, that ticket was assigned to a business unit, and the business unit was clearly identified and marked with those costs. As soon as you have the ability to tag and to enforce that tagging by means of making sure that a resource cannot be applied or stood up unless it is actually tagged, means that now you have a mechanism to track, having trouble with words, tag who is actually doing what, and being able to allocate costs and cost structure back to that business. So in that circumstance, if all of your tagged instances belong to one particular business group, you can then go and say to that particular business group, hey, all of these charges are coming out of you. What are you doing wrong? Why are you overspending? Obviously, having a cost allocation, being responsible, looking and actually proactively looking at the services being used, being able to actually define whether that's the optimum resource for you or whether there's a better set of resources to use that are more efficient. That obviously is part of that shared responsibility. Putting in a budget and review and cost controls. Obviously, there are tools built into AWS that help with that cost optimization. There are third-party tools that will also keep a proactive eye on that spend. But then the kind of elements that we can really, from a HashiCorp perspective, speak to and kind of add value is around the account optimization and the resource control. So the governance, compliance, and regulatory controls, being able to enforce a standardized best practice architecture, and also being able to enforce that tagging policy. How do we do that? Well, we really think about how we can tie those resource control and the enforced tagging back to your budget process and controls without obviously having a clear understanding of what the budget needs to do. Then it becomes really hard to actually be able to save and allocate costs. So how do we go about, what do we need? So the first thing that you're going to need to do obviously is enforce or put governance and control around it. So what we do by that is we can implement forced mandatory tagging. We can put some basic cost controls. So leveraging something like Sentinel, our policy as code engine, you can actually put in a budget constraint. So if this is dev, then here is a cost element that we were associated with that. It cannot be greater than that, and you can actually put that in place. You can then put some proactive checks in place around some Lambda functions or some actual instance killers, that because you have your mandatory tagging, now you can actually go and say, if this resource isn't tagged properly, then we're going to actually turn it off. And it doesn't take very long for developers to learn that all of the hard work that they've done on the Friday and have just got it working gets smashed on Friday night, and they come back on Monday and it's all gone. I know that internally because we use the same process here, and a few times I've forgotten to apply the right tags, or I've mistagged them, and I've come back and found out exactly that, and you go, damn. So obviously being able to then get visibility, being able to track who's doing what, when, driving those through Terraform Cloud or Terraform Enterprise, seeing who made the changes, you now get visibility into who is doing what with your infrastructure. And that ability can be fed back into an existing theme, and now you have a mechanism around looking at getting visible into what actions and tying those actions back to what your business policy is. And then in terms of being able to put some form of control, and this kind of touches on governance a little bit, but in terms of being able to put a governance around where you can use resources. So if you know, for example, that in your dev environments, they don't really need to run that fast. They are purely, there for simple experimentation. Then you can do things like enforcing particular instance types that can only be deployed into that dev environment. Again, leveraging something like Sentinel policy. And that enforces users to only be able to use those minimum standards. And then you can also enforce things like you have a time when they will automatically be deleted as well, or enforcing that you cannot deploy a new instance on a Saturday or over a weekend, for example. So let's take a look at what that architecture looks like. And so here we have an example of some of the elements that are tied together to enforce those mechanisms that we talked about. So we have our Sentinel policy engine. That policy engine has 4 policies. Those policies enforce some of those requirements and governance control that we actually put in place. So as part of the workspace run, when it does a plan, Terraform Cloud has the ability to do a cost estimation. So this is a rough estimate of the resources that are going to be deployed. Now, this is not, and I want to emphasize, this is not a proactive cost management tool. So it does not go and look at what is currently being spent or track what is being spent in any way. It is purely, this is the cost of the infrastructure part that you are going to stand up as part of this plan that will actually go out and be built. So the cost estimation is very much within that context, and we then can use that cost estimate for that budgetary controlling. So is it an instance type? Is there a value proposition? Tie those things together. When we're ready, we then apply that. That then goes away and actually builds that allocation into, or infrastructure, should I say, into our VPC. And in that VPC, you then have the big stick that is there ready to hit anything that hasn't been tagged using our check mandatory tags. So if someone then came into this environment, stood up another instance, didn't know what the tags are particularly long or complicated or hidden, then they don't know to tag that resource. They stand it up in that VPC. The stop EC2 Lambda function runs on whatever the period that is, whether that's once a day, once a week, once an hour, and shuts that instance down. Now you have a proactive way to actually monitor those costs as they are being built within your environment. So you have preemptive in terms of being able to define governance, compliance, regulatory controls with all of your Sentinel policies. And then you have reactive with being able to go and use Lambda and some of the cloud native features to then look at your enforced policies and tags and use those as your baseline for enforcing your best cost optimization. And so with that, what I wanted to do was just actually go and show you what this looks like in real life. So if we now just, where's my cursor? Where's that gone? Oh, it's over there. Now if we just look at this. So this is Terraform Cloud. What we have here is an actual workspace. So this workspace has been associated with a VCS. So here you can see we have just a simple VCS that we've associated with. So this is my repo. From that repo, we're pulling in a code set. So in the back end, we pull that in. And fundamentally, what we're doing is, for the sake of time, I've actually already pre-run this. So this is an apply that is now waiting to be confirmed and deployed. So if we actually just step through what this is doing, there's a few things here that you can actually see. So you can actually see that you could download the log files. Here we have deployed just a simple Ubuntu instance, and within this, because it's a part of a plan, there are information that will be applied to it after it's already been built. But we have some of the basics. We have an AMI ID, we have an instance type, so we know what it's going to be, and we have some enforced tags. So this is actually saying needs to be provisioned by Terraform. So if we now go down and look at some of the things that I mentioned, we have a cost estimate. So here we have a simple cost estimate of what that compute instance will be. It has an hourly cost, a monthly cost rounded up, and any deltas. So around this, and this is basic costing that we put in using the available APIs out of AWS. This isn't anything that we put costing modules around, but based on that and our architecture, we now have applied our policies. So in this circumstances, we run through those 4 Sentinel policies, and at the end of it, we can see that it has actually passed its policies. So what that means is it reached all of the checks, and we have enforced a soft mandatory. So Sentinel has 3 key elements. So you can have an informational, you can have a soft mandatory, and you can have hard mandatory. Hard mandatory would mean this would stop and would actually not run, or soft mandatory is, in this circumstances, someone with the authority has the ability to go in and override this and deploy. And so in summary, going back to our presentation, there are a few resources that I just wanted to share with you around some best practices. So go and have a look at our white paper. So there is actually a minimized cloud waste white paper that Terraform, that HashiCorp has actually built and put out there. It has a lot of information and really good data in there in terms of how to actually go about this, fundamentally using this same approach. Obviously, go and look at some of the resources that AWS also provide in that shared responsibility. Leverage automation. It will be, whilst it is part of the reason, automation will help you actually get control of any of your cloud waste and be able to integrate governance and compliance into your process. In terms of references, like I said, AWS cost best practices, AWS budget, scheduling, and there is actually, as part of HashiCorp, we have a learn.hashicorp.com On that are self-guided tutorials with a lot of the code and a lot of guided paths around actually being able to experiment with this and let them and be able to see this working for yourself. You can sign up for a free Terraform Cloud account, so you don't actually have to have a sign up for a paid version. There is a free trial which will get you access to these features, so you can sign up for, I think it's a 30-day free trial. So sign up, start using Terraform Cloud. It will help you, manage your backend if nothing else, and then you can actually experiment with this and try that demo for yourselves. So with that, I am pretty much on my time, and I'd like to hand it back to the Westcon team, and thank you for having me.
All right, cool. Thanks a lot, David. And yep, that's a good session, and we hope to see you soon. And yeah, so to all our this audience, so just wanted to remind you that to fill up the survey form that you can see it on the chat box, right? So by filling up the survey form, of course, it's like then you stand a chance to win the lucky draw. So the lucky draw will based on the survey form that you fill up. So yeah, so then upon completion of that, you may just proceed back to the main auditorium. So then we're gonna have a few more sessions, and then yeah, so we see you there.